Hi class, this is Professor Juan. I'm recording this part of the YouTube lecture just right from my office. Here I am, that's me. And this will suffice. I just want to go through some practice problems with you. Where I left off in part 2, this first example I gave, here are the blood values, 7.47 pH, there's a normal range. PCO2 50, there's a normal range. And then 28 for bicarb, there's a normal range. And what we had said was, okay, well, that's high. So that's alkalosis. Step 2, look at PCO2. Well, that's high. That's outside the normal range, but that's not the cause, right? Remember our Rome? Respiratory opposite, metabolic equal. That means if this is the cause, well, that should be low if that's high. So that's not the cause. If this is high, that's equally high, metabolic equal, that's the cause. Metabolic alkalosis with respiratory compensation. That value is high. It's trying to drive the pH back down. Okay, so that was the first example. Let's do another one. Example 2. Call this problem number 2. Basically, here are the values. pH, 7.6. PCO2, 44. Bicarb, 30. What you can do is pause the video and try to solve it yourself, and then unpause it. I'll give you the answer. Here's the answer. Okay, you just go through the step. First step. Well, it's high. It's above 7.45, therefore alkalosis. Next step, look at PCO2, 44. It's in the normal range, not the cause. PCO2 is not the cause. It's not a respiratory alkalosis. Look at the base. That's high. Okay, so high. This is high. Metabolic equal. High, high. Metabolic equal. So far we know it's a metabolic alkalosis. Now we ask ourselves, is the respiratory system compensating? It's not. If it's in the normal range, it's not helping. It would have to be outside the normal range to be a respiratory compensation. So we say without respiratory compensation. Okay? Let's do another one. Hopefully you're going to start getting it if you don't get it already. Example problem number 3. Here's our Rome. Here are the blood values that come back from the lab. First value, pH, 7.5. Second value, PCO2, 25, 20. Go. Okay, pause the video if you like. Here's the answer. So you go through the analysis. That's high again. So we know it's an alkalosis. Go to the next step. Is this the cause? This is high. What is that? That's low. Okay. Low CO2 would sop up the acid. Okay. High, low, respiratory opposite. That's the cause. We know it's a respiratory alkalosis. Last thing, go to the third step. You ask yourself, is the kidney, the renal mechanism, is that compensating? Well, let's see. Is this in the normal range? No. That's low. You ask yourself, low base. Would low base help compensate for a high pH? It would. It would. So we say with renal compensation. And you're done. Let's do another one. Example number 4. If you're wondering how many I'm going to do, I'm going to do 8. Okay? Example number 4, here are the values. pH 7.46, 30, 22. Pause the video, try to solve it yourself if you like. Here's the answer. Number 1, look at this. That's a high value. Okay, that's high. We know already alkalosis. Go to the second one. Is it a respiratory cause? Oh, that's outside the normal range. That's low. High, low, respiratory opposite. That's the cause. Low CO2 drives the pH up. Respiratory alkalosis. Is it compensating? Is the other system compensating? The renal system. If it's a respiratory cause, ask yourself, is the other thing compensating? If it's inside the normal range, it isn't. So, without renal compensation. Let's do another one. Example problem number 5. Here's my Rome. I just use it for reference for myself. Here are the values. 6.9, 29, 19. Okay? Pause the video if you want to solve it. If not, let's go. Here we go. 6.9. Let's see. That's definitely low. That's acidosis. Go to the next one to see if it's a cause. Well, that's low. Low, low. It's not a respiratory cause, but it's definitely low. Go to the last value. That's low too. They're all low. Low, low. Metabolic equal. It's a metabolic acidosis. Low base causes the pH to be low. Now ask yourself, if this is the cause right here, is the other system compensating? It's outside the normal range. It is. It's going to be compensating. A low CO2 value will help raise that. So there is respiratory compensation. Let's do another one. Problem number 6. Rome. Here are the values. 7.2, 36, 20, go. Here's how you solve it. First value, low. It's an acidosis. Second value, low, that's in the normal range, not the cause. Third value, that's low. Low, low, it's a metabolic cause. Low base makes the pH too low, metabolic acidosis. So this one's the cause, is the other system compensating. They would be if it was outside the normal range. It's not, without respiratory compensation. Let's do a couple more. Number 7. Rome. Here are the values. pH 7.25, 48 PCO2, 30. Go. First thing, low acidosis. Second thing, this is low, that value is high. High, low, respiratory opposite. That's the cause. This is a respiratory acidosis. High CO2 levels will acidify the blood, making that low. Okay, that's the cause. Is the other system compensating? Is it trying to help? That's high, outside the normal range. High base would try to help counteract that low pH. There is renal compensation. With renal compensation. Last one. Number 8. Here are the values. pH 7.32, 46, 25. Go. Start with pH, number 1. Looks like you're low. It's an acidosis. Second value, that's high. High, low. High CO2 causes a low pH. This is a respiratory acidosis. That's the cause. Check. Ask yourself, is the other system compensating? If it's in the normal range, which this is, no compensation by the other system. Without, renal compensation. All right, we did it. For your test, you'll have at least a couple of these types of problems where you kind of have to go through, and multiple choice style, you'll have to solve these problems. Hopefully that helped. I'll try to post more on our course website to give you more practice. And of course, you can ask me in class if you're kind of stuck with this. Thanks for listening.